There we go.
Wonderful. Thank you very much. Good afternoon or good evening, everyone. As the case may be, welcome to the Thursday, October 10th version of the HamSCIence Zoom call. As most all of you know, I think we've got all familiar faces on here. We discussed any of the projects, findings, observations, things of interest to HamSci, the ionosphere, the magnetosphere, and things interest to citizen science, ham radio operators that cross over into that realm. And there's obviously a lot of crossover. So that's why we like to work together. We don't have any speakers today per se. We've got a little bit of ham-sci business to take care of. Our friends at NASA will be presenting at the American Geophysical Union Conference in Washington, D.C. in December. And they are collecting information on various citizen science projects related to the eclipse. And NASA was good enough to fund some of the solar eclipse QSO party activities. And so we certainly owe them a good shot at sending them some information. So we'll get into that in a few minutes. A little later on, we got three speakers, I think, coming up in the next month or so. I'll get into that in a little bit. And Nathaniel did some traveling in the last couple of days to West Point. West Point is one of the Grape 1 DRF stations. Dr. Jason Durr helped get us set up there. And he's moved on now. He's out in New Mexico. But most of you should recall his talk about a month ago on a magnetic storm, the May 10th magnetic storm, the Gannon storm. Ironically, speaking of storms, today we're in the midst of another one. I want to do a screen share real quickly. Let's see. This came through from spaceweather.com a little while ago. This is ground currents in the United States. Presumably they're quite high as a result of the storm. And I don't know about anybody else, but I never really thought about electrical current flowing through rocks and soil. But apparently it does happen. I mean, they are conductive, maybe not greatly, but they are conductive. And I see a maximum E field here listed on the screen of 4.7 volts per kilometer. So if you got two electrodes a kilometer apart and put a voltmeter in between them, a really sensitive voltmeter, a galvanometer, you would get a measurement. So this is just one of those interesting physical phenomena that nobody thinks about, but yet are going on around us every day. And it's kind of cool. Unless nobody will get shocked from that, I hope. Let's see.
Well, on the other hand, that actually induces enough in power lines that it can saturate transformers and knock them out.
True statement. Yeah. Ask the folks in Quebec from, was it 1989 when they had a lot of issues for sure.
In 1859, the Carrington event set telegraph offices on fire from the current induced in the lines. So
now you're going to find out how well your house is surge suppressed.
That too.
And if it takes out a transformer, now you're going to find out how good your backup generator does or does not work.
Or how big your batteries are. Pat, do you have something that you want to share with us, maybe?
Sure, let me just share this real quick. I put the website in the chat, but this, are you seeing, am I sharing the right thing? Don't see the
See, we've got a finder window.
Okay, wrong one. All right.
There we go.
So this is my space weather website, mms.rice.edu forecast. And as you can see, we're all condition red right now. And if you come over to forecast data, that brings you to this page. So this is our energy transfer function, the Boyle index, which is a southward BZ plus a velocity term. And we use it in our neural network that we trained back 30 years ago. And it's still working great. So this is the input from the one we had just a couple of days ago, and this is the input we have now. This is the KP that we predicted a couple of days ago, and this is the KP we're predicting now. And so if we and so we predict KP, DST, and AE. So we're now pushing 1200 AE and 200 DST, but it really they're integrals, so they look back different amounts of time. The AE has the shortest look back. The KP has the next longest, and the DST has the longest look back. But so it could be really busy tonight. There's already good auroras in Germany and in the UK apparently, and so when you get in the darkness, go out and look. If this keeps up at this rate, we may hit 8.5.
So KP is the planetary K index. I'm familiar with that. DST and AE, could you give us a short
Okay.
explanation?
DST is the magnetic deviation in nanoteslas caused by the ring current. So it's an equatorial average perturbation, or actually maximum perturbation caused by the ring current, which is westward traveling ring current. So it decreases the magnetic field at the equator. Okay. Now, so like this week it was 100, which is a good moderate storm. The one we had in May was 400. Okay. So right now we're pushing 200 prediction. So the bigger that is, the more the injection of particles. Remember, the May event created a new radiation belt. That's how strong the one in May was. Okay, so then AE is the auroral electrojet, and that is the magnetic perturbation from the auroral electrojet, and it shows you the strength of the auroral currents. And so again, it's measured in nanotesla. So a good substorm will be 1,000 to 1,200 nanoteslas, and if you get enough of these in a row, then you end up with a storm. So this is mostly polar, this is mostly equatorial, and this picks up a little bit of everything. It's kind of mid latitudes. So they're the major activity indices. So anyway, we've been running this in real time since 2003, and we haven't missed a major storm yet.
Well, I think the neural networks thing I think is particularly pertinent because didn't the Nobel Prize in Physics just go to two gentlemen who, and I haven't figured out how this works yet, but how used the principles of physics to help some of the fundamental understandings of neural networks and whatnot.
Yep.
So.
Okay, well anyway, that's my song, and I'm sticking to it. So check this when it gets to be dark at your place, and if this is still high, then you're in for some good auroras. Remember, this is the measurement, the most recent measurement at L1, which is why we can predict an hour ahead.
Yeah, and I
So-
just noticed BZ is still kicking strong negative.
Yeah, well, that's like I said, that's why this is so high.
Right.
The higher the southward component, the larger this will get, but also the higher the velocity it gets higher too. So anyway, fun.
Very nice.
I could show you the equivalent one from May. So I was showing you like 300. This one, the input got up to 600 in May, which I had never seen before. And we predicted KP9 on and off for about 18 hours. So again, this was the blue is our prediction and the orange is what happened. And this is what I'm saying, the DST index minus 400 and the KP index about 2000. And both of those were right on. The DST was measured 400. The KP, the AE was just about 2000. So we have a fair amount of success considering how simple, basically, fundamentally simple it is. But that's just to show you the difference. So we're not in the same category as May. So in May we saw auroras in the Houston suburbs. So we'll keep our fingers crossed.
Well, it's very satisfying to see the facts and figures from then and now to compare them, because obviously when you listen to the regular old news media, it's like, you know, the sky is falling and head for the hills and or into your cave or whatever. Now at least we understand, relatively speaking, where we were and potentially where we're going to be the next day or two. Nathaniel, do you want to share a couple of your pictures from West Point? Because those were pretty interesting, I think.
Sure, I'd be very happy to. Let me get those up on the screen here first. Photos.google.com. Great. So, yes, I got to go to West Point yesterday. Jason Dare, Colonel Laux, Diana Laux, and they both invited me up to West Point yesterday to give a talk to their space physics colloquium class. And so it's only about a 2-hour drive from Scranton, so it was a pretty easy drive, but we had a great time. I also saw Colonel Stephen Hamilton. He is the director of the Army Cyber Institute, which is located on the West Point campus as well. He's also the advisor to the Cadet Amateur Radio Club, W2KGY. So he is in charge of the ham radio club there. So there I am with Colonel Hamilton. And I brought Kung up with me. And there we are with Colonel Laux and Colonel Hamilton in the ham radio club. And then we got to go out on the roof of the hall. I think it was Bartlett Hall. And we got to see their, this is a tri-band plus 40-meter antenna. So it's got a tri-band and a 40-meter on there. Was it RJ antennas, I think? So that's their main HF Yagi. And then this is some of the views of the Hudson River from the roof at West Point. It was an absolutely beautiful day. And as we were driving down, we started to see the fall colors. It was just great. It's still mostly green here, but you can start to see some of the fall colors coming out as well. And it was just really neat standing up there taking pictures of both the greenery and also the buildings, which they just look very stately. They look kind of like castles there. This is a folded dipole that Lieutenant Colonel Matthew Sherburne put up. He was actually a grad student with me at Virginia Tech a number of years ago, and then he was a rotator professor at West Point a few years later. So he installed that, and they still use that for doing some of their space weather activities. I think that's what they have the grape connected to at the moment as well. This is their chapel, which Bill Engelke pointed out earlier this morning that it's very similar to Burris Hall at Virginia Tech, which was inspired by this architecture. And then here's their satellite and EME array over here. And there's the HF antenna. And there they have some GPS antennas and their APRS vertical. Just more looking out. Just go Army, beat Navy. And this is a view from their library. So just a few photos from the, yeah, here's the library photos I didn't have earlier today. Their library has an absolutely incredible view from their reading room. So it's just really neat. And I got to watch Diana give a lecture or a research pitch to some second-year cadets, which are called yearlings. She was encouraging them to get involved in research, and she was teaching them how to read research papers. So, and then this is a couple final photos from the area. They had a ghost. Their physics and nuclear engineering department is haunted. Thayer Hall. So it's just a really, really neat day to go visit West Point and also to share with them what we are doing at HamSCIence. And quite a few, it was neat, quite a few of the cadets, in fact, I'd say none of the cadets in Diana's colloquia class were amateur radio operators. But I think by the end of my talk, I convinced all of them that they should be. And I was able to point them directly to Colonel Hamilton, who is right there, who said, I can help you. We run VE sessions right on campus, so we can get you licensed. So hopefully my talk will inspire a number of newly licensed cadets at West Point over the next year.
Fantastic. Yeah, it's great to see the U.S. Military Academy so involved in space physics and space weather. And yeah, if a number of them get licensed, that'll definitely be a bonus. Any questions for Nathaniel on that one? All right, good. Thank you very much for showing us those. It was pretty interesting. I mean, I think W3USR and the West Point station are going to have to compete for some of the best views from a campus radio station because you're both in pretty good shape.
I think so. Well, I can say from the radio station, we win. Now, if you go out on the roof, then they might have they might be able to compete. But from inside of the radio station, we're top.
Very good. All right, a couple other quick items. I mentioned earlier the solar eclipse QSO party. My original goal was to get the scoring completed and results published within 6 months of the eclipse on April 8th, and I've missed that by about a week. But I am approaching it asymptotically, but I'm like 99.5% done with the SEQP results. I'm working on some of the bonus calculations from the spotting files, which started out at 101 million lines. And that's far bigger than anything I've ever had to deal with, either at home or in my career. So I've learned how to get that down to a reasonable size so I can pull the bonus points out of there. So hopefully we'll see that in the next week or so. And I didn't jinx myself and find some kind of a problem. So the SEQP results are getting pretty close.
Question.
Yes.
What was the grand total number of data points that we captured?
I think in Nathaniel's talk at was it the Antenna Forum at Dayton? I think you quoted around 52 million, I think, Nathaniel, if I remember.
I can look that up.
In round numbers will be good enough.
And Bill Engelke has probably seen most of them because he's been helping coordinate the collection of all that data and putting into the MIT Madrigal database. So that those numbers are really something.
Whatever they are, I can just see the science people now. When they grab that data, they're just going to go, wow. We
are putting in a proposal to do a Frontier special issue on the heliophysics big year, and I would really like to get a HamSCI paper in that special issue as well.
I think that sounds really good.
All right, this is
That's 2023. So this is from April 8th, 2024. At least if you look at RBN, PSK Reporter, and WhisperNet over the US, it's 52.7 million.
Wow.
From the summary plot.
Oh, that's great.
Yeah.
That's yeah. Nathaniel, I can just see some of your colleagues going, wow. And where do you start to analyze that?
Kuldeep is right in the middle of that. He can tell you he's been working with those 52 million data points for some time now. So
yeah, and I can show 1 or 2 slides today.
Sure, if you'd like to do that now, now's a good time.
Ah, sure. Okay. You already saw this from Nathaniel. Okay, so then if we do the epoch analysis of those data, then I mean lining up the total eclipse midpoints and then seeing the feature before 1.5 hour and after 1.5 hour. So x-axis runs from before 1.5 hour eclipse totality to after 1.5 hour. And these are at increasing frequencies from 1.1, 1.8, 3.5, 7, 14, 21, 28. One thing that's really comes out is popping up of 1.8 and 3.5 megahertz. And then right after the eclipse, the long range communications at 14, 21, or 28 megahertz, they kind of fade away. It goes to the space. Now, very interesting one is 7 megahertz.
I have to
It
say,
is-
Kuldeep, that looks like those 14, 21, and 28 megahertz. It almost looks like a more abrupt cutoff than I would have imagined.
Oh yeah, it is really abrupt cutoff here. Yes.
Yeah, that's kind of neat.
Yeah.
And even 7 megahertz too, you can see.
Yes.
Looks like a very abrupt cutoff.
Yes. And 7 megahertz is kind of somewhere in the mid, like 1.8 and 3 megahertz or 3.5. They come up, broaden in the range, and then goes down as the eclipse shadow comes in and goes away. The higher frequencies above 14, they are kind of the lower range, the first hop, let's say, it is more or less continuously there. Second hop gets cut off. 7 megahertz is in between. It was never continuously present in the second hop. It somehow comes in, then cuts off. So like these are continuously present from the beginning and then cut off. These were coming in and going out. This comes up before the eclipse, just half an hour before, and then cuts off. So this is something totally different. And this was not happening throughout the eclipse. So the head kind of thing, or the cap kind of feature here, which is around 4,000 to 6,000 or 8,000 kilometers, let's say second hop or longer range communication. If we identify when it was happening during the eclipse, so this is on the top is previous day and the bottom is the next day or eclipse day. Those HAT or the long range 7 megahertz communications were happening or opened up later in the eclipse. So eclipse was between 17 to 21 UT. That same feature did not appear throughout as the eclipse travels. It appeared in the later 1930. Now, there can be two candidates which can have a sort of explanation for this, which we are thinking now. Now, first is we in the HamSCI community know that the western side of US is well populated with the transmitters or the hams. The beginning path was not so much populated in terms of the transmitter receive locations. Is it that, or is it because of something which we are thinking? So it could be this also. Let's say where was the day and night contrast and how the eclipse shadow was moving as the day and night boundary was also traveling. So 1830, eclipse shadow is somewhere in the south. Then we have a clear demarcation between the day and night. This is night shadow and this is day brightness. If you go at 1930, the eclipse shadow and the evening, so sunset thing, kind of merges. It could be the possibility that these shadow related to the eclipse and sunset, they kind of have a broader channel where an extended evening or extended eclipse kind of shadow. So this path really gets lower densities in the D region. So the band which is really closer to the maximum frequency of the ionosphere that gets most affected, which is 7 megahertz. So that's why 7 megahertz kind of lingers between a continuous connection and sudden drop, or opening up and once again drop in the lower frequencies. So this part is somewhat related to the eclipse part plus the evening part also. And we have kind of got the indication of it Now, this picture actually strengthens that point. The previous day, which is on the left, and the right one is the eclipse day. So what I did is, let's say where was the eclipse totality at 1930, because 1930 is the time when we see that 1930 onwards, this hat 7 megahertz second hop comes in. So 1930, where was the eclipse shadow? It was somewhere here in the northern eastern part of US. Let's track that geographic location, how it was behaving before and after. So let's track the transmitter, how they got connected only from that geographic location. So before, they were connected to the US continent within. Later, it got really open to Europe, which we have seen in one or two HamSCI discussions now, that there was earlier opening. So this band, it opened to US, from US to Europe, is probably because of the evening there and sunset being evening or sunset being in the European side, and eclipse shadow, they kind of merging here. And it kind of creates an extended sunset thing or extended eclipse shadow. And our middle range, which is 7, it behaves differently. Whereas the lowermost 1.8, 3.5, or the uppermost, well above 10, 14, 15 megahertz, they have a good similarity among them, like 1.8, 3.5 are similar, higher ones are similar, 7 megahertz, mid one. It kind of have convolution of both evening effect and the eclipse shadow. That's what the thought is at present. The ray tracing can really nail it. So
That's really nice, Kuldeep.
yeah, thanks. This is what I showed in our today's NASA Telecon, which you had shared.
Oh, great.
Yeah,
How did they like it?
it was good. They really liked it, and so yeah, it was overall good. And they were announcing the new citizen science projects which got accepted, and then some of the science results or ongoing works which we are doing. So in that part, I presented it. It was good. They
Oh,
liked it.
good.
Yeah,
That's great.
Yeah.
Thank you for doing that.
thanks.
You're
So
welcome.
yeah,
So question.
yeah.
So I'm looking at the 14 and 21 megahertz drawings or diagrams there.
Mhm.
And so if I understand what you're talking about correctly, the reason we're seeing such a sharp drop off after the eclipse, it like somebody's turning a switch
Yeah,
off, and that's due to the influence of the sunset coming on from Europe, because otherwise you might expect, how should I want to say this, and I may not be using the right words,
yeah.
a fade. In other words,
Gradual.
as the eclipse starts, it would fade one way or the other, and then as the eclipse ends, it would fade out. The effect would fade away, and you'd get back to what you would normally expect at that time. However, so what you're saying is the effects of the oncoming sundown from Europe, the oncoming sunset, that affected what we're seeing
Yeah,
right now.
yeah. So that part is definitely true for what we are thinking in terms of 7 megahertz. For 14 and 21, since it could be the case, but at present, 14, 21, or 28 are significantly higher, double the ionospheric plasma frequency. So what my thought is, it is pure eclipse effect on the right hand side, 14, 21, 18, 28. In the middle, 1.8 lower side, which are significantly lower than the ionospheric frequency, 1.8, 3.5. So significantly higher or significantly lower. That is pure eclipse, dominated by eclipse. But
So,
the middle range, 7, is closer to the maximum frequency of the ionosphere. So middle range got combined effect of the evening and the sunset extended.
So
That's
is this the first time that this kind of, that anybody's aware of, that this kind of an observation has ever been made?
With my, I mean, 6 or 7 months of experience, I guess not, but I guess Nathaniel or Gareth will be more aware of this part of the literature. I believe this is new.
If it's new, it sounds like a good paper.
Yeah, yeah,
Woohoo.
yeah. Thanks. Yeah.
Interestingly, the eclipse in 2023, the annular eclipse,
Yes.
coincided with darkness to Asia going in the other direction.
Yes.
And I know on the medium wave data, we did see some signs of Asian signals coming back up again after local sunrise at the receiver. So that might well have applied with the data from the 2023 eclipse, only looking towards Asia at sunrise.
Okay.
No, this is fascinating, Kuldeep. I mean, not only your conclusions here, but to have watched you over the past few months arrive to this point, and I know you're going to continue. There's much more to see, I'm sure. It's been interesting to follow your thought process throughout the months here on this call. So thank you very much.
Thank you. And those 52 millions of data points, I had to find out ways in Python to not run the loop, which was problem side. But the good side was I found ways I can process it faster. And that's really a worth golden data set, I can say. It can have much more. We can have many things on it. Yeah.
And this would be an excellent presentation for the March HamSCI there at NJIT.
Yeah. Yeah. Yes.
It'd be really cool.
Yeah. Thank you.
Just to answer a question there too, I think Nathaniel did an epoch analysis in his 2018 paper.
Yes.
Oh, there it is. Yes.
Yeah.
Look at the 7 megahertz there. There's that little, it's not as, I guess, finely resolved to what's Kuldeep showing, but there's at 7 megahertz. So panel C right there at the longer distances, there's a little bit of something. Yeah. I'm also surprised, taken aback, whatever you want to call it, by that sharp drop off.
Oh, yeah.
We see,
Yeah, I would
but it's
really, to me, that was one of the most striking features of the figure.
Yeah.
Yeah.
One
No, it's
thing. Yeah. Sorry.
I was going to say it also, I had a big smile on my face because it really ticks a box on the grant that is sponsoring this research, where we said we wanted to look at asymmetric responses, and that is the most asymmetric response we could probably ask for. So
I wonder if that will show up in the ray tracing.
we will find
that's
out.
Next. Yeah, we will find out. The figure here was from 2017, but HamSCI has grown so big that we have number of data points, I guess, many folds. So the bin size here was, we were averaging 500 kilometer bin and 10-minute data. But the figure which I showed is actually increased in both. So there is a 5-fold final resolution. This is 100 kilometer bin size and 5 minutes of bin in the temporal resolution. So because of humongous amount of data which you all have collected, we can go much finer resolution both in the temporal domain and in the spatial domain. So thanks to HamSCI.
Excellent. Thanks, Kuldeep. What I'd like to do is draw that part of the call today to a conclusion so we can jump into the information we need for NASA, because that's got a hard deadline as well. So we'll see more of the information to come out of our 52 million spots in weeks ahead. Nathaniel, do you want the information that the NASA folks are requesting? I'm going to throw that up on the screen real quick so everybody can see what we got from
great.
Joy. Let's see. Here it is. So there you can see that, and NASA is planning a pitch for an AGU panel about the eclipse results. Great. In addition to the panel, we'll publish results in a NASA article and likely a video around the same time as the panel. So this would probably encompass many different citizen science projects, not just HamSCI, but would just be one of many. To help us with scripting and planning, could you answer some questions below? How did the Eclipse project go from your perspective? I think we'd all agree that went well. Will you release any findings by the end of 2024? So on and so forth. If not, when do you hope to have it finalized, and what do you plan or kind of hope to do next? So NASA is basically just asking for general information of what we saw. Were we pleased with what we've seen so far? Do we have any results? And when might they appear? So where do we go from here in trying to answer those questions?
I think for me, and maybe I want to hear Gareth's opinion on this. So a lot of those questions I think are fairly straightforward to answer because we have really nice figures, at least from a PR perspective. We have really nice figures of the grape Doppler observations and the Whisper Demon Doppler observations that I think we can, explain fairly well and that are part of the eclipse. I think, that's no problem. I think, we can say that we had lots of participation in the solar eclipse QSO party. We have really nice summary plots that show the eclipse results. The big one that Bill Engelke made up earlier, and then these nice plots that Kuldeep is putting together. We've got great, Nick Hall Patch did a wonderful job with the medium wave event, and he has quite a bit of compelling plots. I think Jonathan has some nice VLF plots. So I think we have some really nice things where we can say, yeah, we really had a lot of people participate on a lot of different experiments, and we really got some beautiful observations that clearly show the eclipse. And I don't think that's going to be too hard to say. But what I'm not sure to say is this question that says, did we learn anything surprising? And the reason I'm afraid of that question is a couple of reasons. Usually if you learn anything surprising, you want to get it like peer reviewed, number one. Number two, before you go, telling the whole world about it. Number two, there's a lot of stuff that's been out there about eclipses already. So I'm not sure, I'm not sure how much of what we're seeing is surprising, but I'm not sure, but maybe Gareth and maybe Pat, and if even Kamal, Kuldeep, maybe you have some thoughts about how we respond to that.
Yeah, I guess in terms of the surprises, I think, we were just surprised by that asymmetric response we were just talking about. So there's those kind of surprises.
Yeah. We could say that, but show that, but we could say, we're still investigating it.
Yeah, I think in terms of just HamSCI and some of the data results that I've been seeing from, and this is because it's HamSCI, it's essentially all eclipse related data sets. One thing I'm surprised about is I think I'm just surprised about how many open questions there still are about the basics of like propagation, what propagation modes we're seeing, but also how many open questions are about just the eclipse in general and the eclipse's effect on the ionosphere. Eclipses have been happening for a long time. Radio's been around for a long time, and we still have these like very fundamental questions that, to me, I think just looking at the data, seeing like Kuldeep's results, seeing other results from the grapes and all that kind of stuff, it's very it's surprising but encouraging and exciting that there's still some really interesting questions, compelling questions that are still there. And then
I really like what Kuldeep picked out about the interaction of the eclipse shadow with the dusk terminator shadow. Kuldeep, do you have any idea how many other eclipses have that sort of geometry where the eclipse shadow ends up interacting with the dusk or dawn terminator?
Not now, but I can tell it by tomorrow. I can check 10-15 eclipses and I can come up
I mean, that might be something interesting to note because, you pointed that out, which I think is a really neat observation. I have no idea if every eclipse ends up having a condition like that, or if I have no idea how rare it is and, how novel it is, but that potentially is an interesting aspect that it's certainly not something I've heard people talk about a lot. What happens where the eclipse hits the terminator?
Nathaniel, question.
Yeah.
Um, looking at the data from the eclipse 6, 7 years ago, we saw that you know I want to say cutoff or dropout. When the eclipse ended, there was that change in value. Is it the case when we look at the data from this time versus that time, we can see that it happened before? We just didn't know what we were looking for. We just didn't think about it or notice it or pay attention. But is it possible that we actually observed it that many years ago, and now we can
Are you talking about the dusk terminator?
yeah. In other words, especially in C, in diagram C around 7 MHz, where you can really see it. No, go up to right there.
Yeah.
Is
Okay,
down
so
below?
this is the asymmetric cutoff that we're talking about. Yeah, I mean,
Yeah.
I think after Kuldeep showed his plots today and pointed that out, it does in fact look like there is some sort of abrupt cutoff there at 7 MHz for the second hop.
Yeah.
I mean,
So
it's certainly, I can tell you that I have, out of convenience, ignored the second hop for all of my studies so far because I've just said I'm just going to look at the first hop because that's easy to explain. So certainly, Kuldeep, looking at the second hop, my hat's off to you. And I think that is also a nice thing to talk about.
yeah, I mean, if when you go to make your submission to NASA, you can say that we just observed this. Okay, I'm just ad-libbing it here. We saw the effect in the data from 6, 7 years ago. We just didn't pay any attention to it. But now going back and comparing what we saw back then with what we measured this year, we now see that there is something in it. So we can, for lack of a better word, better choice of words, we claim the prize of having found it.
Well, I wouldn't say that we didn't observe it or whatever. I mean, you think about it, we've got far more spots this time around to work with. We've got a much larger data set. The computing power that we can apply to these problems and the software tools for visualizing them are far better now than they were 7 years ago. That's a lifetime in the computing world. So,
oh, I agree.
It's not a surprise that we're learning more, I guess.
So yeah, I was just trying to go back and claim, see if we could claim some credit for it. Even
Well, I think Nathaniel is being judicious too. Is when you in the science world, what I've learned is when you claim something new, you have to be careful because you want to put it through the peer review process.
yeah. Well,
and so we can't, you just have to take your time and do things in the right
I
order.
get it, but again, my thesis is there possible that when you do all that, you write it up, you peer review it and everything, that we can claim that we got the data first, we just didn't pay attention to it.
Well, it's not like it's a little different than a patent, I guess. If it was in your patent notebook, it's kind of the same kind of thing. But so let's talk about, okay, so you've got some good ideas or anything. How do we go forward and gather some of this stuff and prepare whatever it is we want to prepare for Joy?
That is a good question, Gary. Can you put
$10 million question.
Can you put the figures or the questions on the screen again?
Sure.
Well, I know we have an answer to 4 as well, right? What do you hope to do next? we probably
Mhm.
have a couple of ways to frame that, right? So, in terms of, there's no eclipses, and HamSci's been very focused on eclipses, so it's time to kind of put our efforts towards other geophysical. Well, this is my soapbox, geophysical phenomena like the storm we're having right now,
Yeah.
and applying the same rigor and observational capabilities to these other events as well.
But
I
I
think
think
the
that
way I agree with that, Gareth. And I think going along with that, yeah, I agree.
Well, the
Um,
DAISY 2 grant, though, also is going to significantly improve our instrumentation and create get a much greater span of information. We're going to have medium, we have low frequency, we're going to have the magnetometer data in addition to the HF receivers, which that technology is improving too, with all the whisper signs and so on and so forth. So what we
Yeah.
plan to do next is not only study new phenomena, but study it in new and more rigorous ways, I guess I'd say.
Also, like although we're not having any North American eclipses, there are eclipses in other parts of the world, 2027 across North Africa. I mean, having set up, this quite productive system of recording data, it seems foolish to sort of just say, okay, well, we've done that and we'll pass it on to the next generation sort of thing. So this may well be information that will be passed on to to others, and maybe HamSci, get some HamSci participation from Europe and North Africa.
And Nathaniel, would you like me to I'm going to start, would it help to kind of have an outline of some of the things you've mentioned? I was taking some notes, and then
It
we'll
would
see where we
help
can,
immensely.
all right. And then we can get the figures and stuff to plug into there over the next couple of weeks. Cause today's the 10th. They want this by the 31st. So that's 3 weeks. And we've got obviously other things going on in between. So
Yeah, that would help immensely, Gary.
yeah, I'll start that and keep in touch.
Yeah. And then you could show it on this Telecon again, and then we can suggest to add or change things or stuff like that.
Okay. I will put that on my to-do list starting very soon. Any other comments from you or from the rest of the group on these 4 questions? Okay, so know that some of you I'll be knocking on your mailboxes to at some point to gather some of this information. So fantastic. Okay.
Is there anything else on the agenda today, Gary?
No, I was just going to mention some upcoming talks, unless you've got something else you want to bring up.
I think Jamal, he just had an abstract accepted to the European Space Weather Week, and I think he's starting to prepare a presentation, and he might have some slides ready now that he could show, but I would be very interested in having him show that, possibly at least give us a brief overview today, and then over the next few weeks, keep us updated on the progress he's making on that, because his talk's gonna be November 4th through 8th. You want to make sure that he's well prepared for that, because in some ways his talk will be one of the first, or HamSci talks over in Europe. It won't be the first, but he's certainly going out there to wave the HamSci flag. So it'd be really nice to hear what he has to say.
Hey, Dr. Nathaniel, but I think I might take much more time than the remaining 7 minutes. So, would you like that I can give a quick skim for this, or
Well, yeah, why don't you just give us an idea of what you're doing, just like 2-minute elevator pitch. And then do we have some time next Thursday, Gary, that we're able to?
Yes,
Yeah.
that would be fine next Thursday. Yes.
Okay, great.
okay, that's fine. So, apologies for not having this 7-star presentation, but there is a quick scratch about it. Actually, the presentation goes around having a system that might work in parallel or as a backup to the GPS system. That's really promising dream, but let us work on the first initial steps by having a system that can perform localization or location estimation for users, but using the HamSCI network. So this project or this research leans on the existing Intel Whisper network hardware deployed since 2021 by Dr. Roland. Actually, can you see the presentation?
Yes.
Yeah. So the team that deployed this project is IU2PJU team. It was in 2021 at Milano, Italy. And actually, it was on the ground station deploying different types of antennas. Actually, I captures the most important three of them is for example the Skyloop antenna and the DX Commander, the QTech penetrator antennas, and I investigated the pattern and the performance of each of them and how can they serve to obtain the purpose of localization. So here is an example of them. I took actually it was a question and it was posted by Gary. Do you remember this, Gary, last year? In order to obtain the localization purpose, we should have antennas that look like omnidirectional one. So the question was, how did you know that they are omnidirectional? So the answer is they are not purely omnidirectional, but working around and investigating the most appropriate tilting and profiling, we can get that omnidirectional performance. For example, this is Skyloop antenna, and apology for this not clear prototype of the antenna. Here is a house. I'm just describing the size of this Skyloop antenna. Here is a house, and it can be protruded like this way, like a loop in the sky. So the answer to the question, how do you know that it's an omnidirectional, is by working around by tiltings in order to get a performance that looks like this red one. So the figures are not clear, but if we manage to have the 60 degrees elevation angle, then we can have this kind of performance, which is this purple one. So, and we can say it might act as an omnidirectional performance. So again, we are going to have another example, the inverted L antenna, and the question again, how can we say that it's an omnidirectional antenna? And the answer is, at this kind of antenna, actually, depending on the plane we are going to investigate, we can have an omnidirectional or none. For example, if we're going to investigate the azimuth plane, the azimuth radiation pattern, so we can get this performance. And this is very promising. That's really nice. You can tell that this antenna is omnidirectional. But if we're going to investigate the elevation radiation pattern, it's not omnidirectional at all. So we should have this kind of elevation in order to get the most, or in order to get the best out of this radiation pattern. So again, we should believe that it's not they are not only pure omnidirectional one, but we're going to have some workarounds to get this radiation pattern. Here is a plan. Here is a map showing the coverage of this antenna, and again we can say it can be used as an omnidirectional one. So why are we going to investigate this omnidirectional pattern? Why? Because if a user, for example, is going to be located at this point with respect to the antenna itself, so we would like to have this user to have a fair chance to be covered by this antenna if it's going to cover its location. So if we're going to use a very targeted antenna, so we might miss the chance of being covered by the antenna itself, and then we're going to lose the function of localization.
Kamal, I have a question for you. On the Sky Loop, you said it was like 635-foot perimeter?
Which one? The Skyloop antenna? Yeah.
The Sky Loop, yeah, your previous slide.
Yeah, sorry.
That's
Yeah. I'm
a
getting.
long
Is
wire.
that clear? Is that fine?
Well,
I'm just.
no, but
Can you see it?
that's a very large antenna, and that's not a Skyloop 80 to 10. A Skyloop 80 would be 270 feet perimeter.
Is that better?
No, I'm saying that 635 feet does not make sense.
Okay.
A Skyloop 80 is 270 feet perimeter.
Okay. That's really nice. Can you just write it down?
Now, what do
These
you mean
figures,
by perimeter here? Do you mean the length of the antenna, or are you measuring it at 635 feet? I don't understand this.
Yeah. Based on the source itself from pile U up dx, actually, they figured out the numbers as that they would like to have a perimeter of 635 meters covering the perimeter of the antenna itself. So
Well, is
I
it feet or is it meters? You just said meters. But
okay.
I think I'm looking at
Can
the
you
Skyloop website right now. The Skyloop
Right.
2.0, it says it's 286 feet of wire is
Correct.
included.
Yeah, it's a little larger than a wavelength.
I will have to I do have to sign off now so I can
Okay.
go. Otherwise I won't be able to have dinner with my family, and then I have to dash back out here for open station hours. And I've been doing nothing but school except since 8:30 this morning. So but I do want Jamal, I do want to I think it'd be really good if we do have you on next Thursday and we keep talking about your presentation.
Right.
Does that
Could you send a link to what you used for these
Sure.
this diagram?
Okay, 1 moment.
Thank you.
Okay.
I use a Skyloop. I use a Skyloop 40
That's
myself,
really
so
nice.
I know the antenna.
Okay, that's really nice. I'm really glad for this feedback. Okay, 1 moment. It's found at the end of the presentation itself in the references section. Okay.
Hello, guys. Oscar Hotel 8, Sierra Tango November here.
Yeah. It's a phone
Thank you very
number.
much, everyone. I will see you
Doctor, can
in
you
a
give
week
me
or
your
so.
mail? I will send it by email, okay? Can I have your mail right
Yes,
now?
thank you.